All right, so the second part of solving exponential equations. We're going to have quite a few more steps with this one, but it's one where it's just a new way of solving, and especially with our logarithms and with everything in algebra, it just takes practice. So we'll see some examples here, but then again, I highly recommend the participation for just seeing lots more examples. But in general, these are going to be the steps to follow. So where we're going to start here is taking the logarithm of both sides of the equation. And similar to using the change of base formula, we can either use base 10 or base e. Doesn't matter which one as long as it's consistent. The only tip I'll throw in there is if you look at your exponential forms and one is base 10 or one is base e, then I would go with that logarithm. So like if instead of 3 right here it was a 10, then I would definitely use logarithm base 10 because there's those nice properties of when you take a logarithm with the same base as the exponent. Same thing if I saw e show up, I would go with that natural log. In general, I go with natural log, doesn't matter which one though. In fact, if we go through these examples and you want to try it out with logarithm base 10, you can go through the same process and see that we'll get the same answer out. So what this will look like, so I'll kind of refer back to these steps as we go through this first example here. So what we're going to do is take the logarithm of both sides of the equation. So what that would look like is I would take logarithm and logarithm. So we would have the natural log of 3 to the x plus 1 equals natural log of 4 to the 3 minus 2x. So that's step 1. Our second step is to use the exponent property to move the exponent out front. So what that means is we can see our exponent inside the logarithm, and the property says that that exponent can come out front and multiply with the logarithm. So we'd end up with our exponent multiplying and then just logarithm of the base. So that's what we're going to do here. What's different here is that our exponent is an entire expression in both cases. So when we move this, we need to move it with parentheses around it. It's like we have this grouped expression. So this x plus 1 is going to move out front to multiply with that natural log of, and then just the base 3. So what this will look like is we'll have exponent of x plus 1 times our logarithm of 3. All right, and if it helps, you could write the multiplication symbol in between there. That's great too. So we're going to do the same exact thing on this other side. We're going to take out that exponent of 3 minus 2x in parentheses times natural log of the base of 4. Okay, so our next step, step 3, is distribute. Nice and short. But this distribution looks a little different, again, because logarithms are still a bit new for us. What you can imagine is this is just a number. If we type in natural log of 3 into a calculator, we're just going to get a number back. So with that, we have this number multiplying an expression where we have multiple terms. So this is where distribution comes in, is because we would distribute that constant into the parentheses in order to carry out that multiplication. Same thing on the right-hand side, we have just this number coming through here, and to multiply with an expression with multiple values adding or subtracting together, we would need to distribute in. So that's what we're going to do here. We're going to distribute so it multiplies with x, distribute so it multiplies with 1. So we're going to have x times the natural log of 3 and then positive 1 times natural log of 3, which is just a plus natural log of 3. So we carried out that distributive property. And now what we're going to do is the same thing on the right-hand side. So natural log of 4 is going to distribute in. So we'll have 3 times the natural log of 4. And then negative 2x times natural log of 4. I'm going to go ahead and write this. I'm going to bring the x out front just to kind of, the only reason is to kind of match the format that I had over here where I'm putting x out front and then the value. So I'm going to put x out front, but then we'd have 2 times natural log of 4. All right, so with that, we have simplified both sides of the equation. It might not look that way, but it is in fact simplified because the multiplication's carried out, and it's all kind of expanded out. So that takes care of step 3, we distributed, and now step 4, adjust any values using the properties of logarithms. And the property we're going to use is actually this logarithm property here in reverse. What we're going to look for is numbers multiplying with our logarithm and switching it so that it's inside the logarithm, just because we have all these numbers hanging out. If you don't do this step, you can actually get through all of this work fine. And in fact, I'll be totally honest, when I first made these lecture videos, I did it without this step. However, it gets very messy. There's just a lot more little pieces if we do that. So I recommend this step for just kind of condensing pieces down and making it a bit clearer. So what I'm looking for is this number outside multiplying with the logarithm. I don't want to use that property here. I don't want to put x in for the exponent there because the whole idea is getting x out of the exponent. So I'm going to leave that alone. Same thing with natural log of 3. I don't have anything multiplying out front, so nothing going on there. So I'm leaving the left-hand side of the equation alone. However, on the right-hand side of the equation, I'm going to simplify this 3 times the natural log of 4 to be the same thing as the natural log of 4 with an exponent of 3. So instead of writing it out as 3 times the natural log of 4, I'm going to replace that with the natural log of 4 cubed, which is 64. So just a little simpler having the number contained inside than having numbers on both the outside and inside. I'm going to do the same thing over here, where I'm going to have minus x times, and then instead of 2 times the natural log of 4, this is the same thing as the natural log of 4 with an exponent of 2. I'm going to rewrite that as the natural log of 16. So it's up to you if you want to do that step. Again, you can get by without it, but what I did find is with the numbers out front and inside, it can just get a little confusing. So that was step 4. Now we're at step 5 here. And this step is exactly what we do with linear equations when we have x on both sides of the equation. The idea was to get everything with x to one side and everything else to the other. So that's what we're going to do here. Any terms with x we're going to put on one side of the equation and all the other values go to the other side. So my terms with x that I want to put together, I have this x times natural log of 3 and this minus x times natural log of 16. I'm going to go ahead and take the step of moving that term over to this left-hand side, mostly because I like to add things and make them positive. But just like with linear equations, if you moved x natural log of 3 to that side, you'd get the same answer out. So what I'm going to do is add x times natural log of 16 to both sides of the equation. So we'll have that taken care of. So that'll get all of my x values on the left-hand side. However, I'll still have this little extra natural log of 3 over here. So I want to move that as well. I'm going to go ahead and do this in one step. If you want to separate it into 2 steps, that absolutely works as well. But subtracting natural log of 3, subtracting natural log of 3. So when we do this, on the left-hand side of the equation, those natural logs of 3 cancel out with each other. So all we have is this addition of x times natural log of 3 plus x times natural log of 16. And then on the right-hand side of the equation, that x natural log of 16s, those cancel out. So we'll have this natural log of 64 minus natural log of 3. So what we can see now, everything with x on the left-hand side, constants, again, like if we just type this into a calculator, it would just be a number over there. We just don't want to calculate the number yet, because if we round too early, we'll just keep compounding the error over and over and over again, and you'll get an answer that's completely wrong. So we want to have this exact answer, type it all into the calculator, and get a decimal answer right at the end. Okay, so that was step 5. Step 6 is to factor out our variable and adjust any values using properties of logarithms. So what we're going to do is factor out x. So again, factoring is the idea of like dividing it out from each term. So it's like we're dividing by x and dividing by x. So we get this x out front. And then what we're left over with is just natural log of 3 plus natural log of 16 equals natural log of 64 minus natural log of 3. So this extra piece of adjusting any values, what we're going to do, and again, this is a step you don't have to do. We can divide at this point and be perfectly fine, but it might be easier with this step. So whichever you prefer. So what I mean by dividing at this point is we would divide both sides by this whole natural log of 3 plus 16. So you'd have this big denominator here, and that would be your exact answer. And that's great, and you can type it into the calculator. But if you want to make this a bit simpler, what we could do is combine with the fact that we're adding 2 logarithms here. So really this is the same thing as x times the natural log of, and then what we would do, since it's addition, we would multiply 3 times 16, which is 48. So that's coming from 3 times 16. And we could do the same thing over here of combining this into a single logarithm, since there's subtraction between them, of 64 over 3. Since 3 doesn't go into 64, we would just leave it like that. Oops, sorry, that was my dog shaking off. All right, so at this point, we can divide both sides by this natural log of 48, divide by natural log of 48, which would be x equals, and then we would type that into a calculator. So we're going to have a fraction. We'll have natural log of 64 over 3 over natural log of, and I forgot, 48. For 0.7905 for a decimal answer. So for an exact solution, we would have this division here. For an estimated solution, we have this solution here. Of course, before I box those, we should check that it works. So taking that 0.7905 to our original question, so 3 to the 0.7905 plus 1, is that equal to 4 to the 3 minus 2 times 0.7905? So what you could do is type both of those into the calculator. 0.7905 plus 1. And then comparing that to 4 raised to the power of 3 minus 2 times 0.7905. And you can see, again, it's going to be a little bit off, but you can see like that would round to 7.15, 7.15. So that's close enough with a rounded value there. So that checks out. So quite the process here. I know we're at about 15 minutes in this video, and I am gonna go through another example here. If you need to pause and take a break. This next example, I'll go a little bit more quickly through with the steps up above there, but this is how we would go through the work. Again, like I said, there are areas there where I'm condensing the logarithm and just kind of making it simpler to work with. But you don't have to do that. In fact, I could even show you without condensing anything, so without making those adjustments that I mentioned up above there, what you would end up with is 3 natural log of 4 minus natural log of 3 over natural log of 3 plus 2 times natural log of 4. So that would be the solution if we didn't condense anything. So without putting the exponents inside, without switching to division and multiplication, this is the same exact answer and just as correct. So whichever way you prefer works for me. Okay, another example here. So we're going to I'm going to go a little more quickly with this, but again, the participation will get more practice. Natural log of both sides. Natural log of both sides. And what I'll go ahead in this step is kind of combine, because our whole point of taking the logarithm of both sides is so that we can get the exponent out front. So we'll have this exponent out front of x plus 3 times natural log of 2. So we just have the base in there now, equals exponent of 2x plus 1 times natural log of 5. Our next step is to distribute the natural log into the expression. So we'll have x times natural log of 2 plus 3 times natural log of 2 equals, I'm going to bring the x out front here, x times 2 natural log of 5 plus 1 times natural log of 5, and that would do it. So there's everything expanded out after putting our exponent out front. Then I'm going to take a moment to condense things a bit. So moving any values multiplying with our logarithm outside to being an exponent. So I'll still have this x times natural log of 2, but where I have this 3 natural log of 2, this would be the same thing as natural log of 2 to the 3rd power. So I'm going to change that to natural log of 8. And over here, this would be 2 natural log of 5 is the same thing as natural log of 5 squared. So I'm going to adjust that to a natural log of 25. All right, then my step is to move everything with x to one side of the equation. I'm going to move it to the left-hand side. So I'm going to subtract x times natural log of 25 from both sides of the equation. And then I also need to move away this natural log of 8, so I'm going to subtract that from both sides as well. So when I do that, I'll have these cancellations where that natural log of 8 will cancel out with itself. On the right-hand side, that x natural log of 25 will cancel out. So on the left-hand side, we'll have x times natural log of 2 minus x times natural log of 25 equals natural log of 5 minus natural log of 8. All right, my next step is to factor out x. So I'm going to bring x out front as a factor, which will leave us with a natural log of 2 minus natural log of 25 equals natural log of 5 minus natural log of 8. Now, if we want to condense things down here, what we can do is condense down this subtraction that's between two logarithms. So to do that with subtraction, it would make division of your two pieces where we'd have numerator of 2, denominator of 25. So we can condense this into a single logarithm of 2 over 25 equals, same thing over here, since it's subtraction, we can combine it to a single logarithm, numerator of 5, denominator of 8. So to get x all alone, what we're going to do is divide both sides by this natural log of 2/25. So that on the left-hand side, all we'll have left over is x. And for an exact solution, we'll have this natural log of 5/8 over natural log of 2/25. And to get a decimal estimate, we'll go to our calculator. And I'll make my fraction natural log of it's hard switching, 5/8 over 2/25. Okay, got that. 5/8 over natural log of 2/25 for a 0.1860. Or sorry, 0.1861. And then when we get to the end here, we want to check by going to the 0.1861 plus 3, and does that equal 5 to the 2 times 0.1861 plus 1? So let's check that out. With these, especially after all of that work that we just did, I really recommend checking your solutions with these just to know with 100% certainty you have it right. All right, there's our value with 2, and then with a base of 5, we'll have 2 times that 0.1861 plus 1. And super close there. So I usually look at probably the first 2 decimal places. This gets even better too. But usually the first 2 decimal places or first, that's perfect. Okay, so that checks out. So we have our solution there. Okay, just real quick, because I know this is quite the long video, but I did want to go back to our original cases and show you that this method would work. Although maybe now that we've gone through the steps, you can tell why I would avoid that method if I didn't have to do it. But it does work here as well. So let's say I just see I have a natural log expression, and I say, well, then we take the logarithm of both sides. So I think I said logarithmic expression. It's a exponential equation. So with that, taking the logarithm of both sides, which means the exponent moves out front, so we'd have x times natural log of 3 equals natural log of 15. And this is a lot simpler because it's just x in the x that's multiplying, so we don't need to distribute. So all we would do is divide by natural log of 3, divide by natural log of 3, and where we're starting to see our solution here, you can see how that compares to our change of base formula. So we get to the same exact spot, taking the logarithm of both sides. You can kind of avoid that change of base formula with this one, but you get the same exact thing coming out. So if you wanted just a single method to apply to all exponential equations, then it would be this method that we just went through here. It's just when they're simpler, you'll have some steps you get to skip over.